Yes, my name is Sandeep. My subject is electric utilization, and my topic is about optimization of selected electroheat models based on calibration of material properties. Introduction. One serious problem of influencing occurrence of numerical models of various electroheating process and uncertainties in temperature dependent properties of involved means. These properties are well known as for pure metals, but in the case of alloy, they are often known as only approximated unknown, generally depend on chemical composition, homogeneity, their structure, and even same alloy produced by different manufacturers and exhibit unequal parameters. The paper presentation techniques calibration of characters based on the evolution experiment obtained heat affected zone, both thermal conductivity and product of specific mass, space, heat, and the PCR replaced by approximate function. Those coefficients are subjected to optimization when difference between the measured and modeled temperature profiles. The methodology is illustrated with example of assisted laser welding to description of problems. Welding belongs to advanced technology for more than 20 years in the industry, and the process of characterization by the extremely high growth of temperature in order to thousand case will lead to a crash of peeling of the welds or other damage caused by the mechanical stress, thermoelastic or thermoplastic origin, residential stress control. The result from manufacturing process is also very important. One of the ways of reduce is the temperature gradiently by preheating or post-heating the material by magnetic induction. The arrangement is schematically inducted. The full model of process is magnetic and induction arrangement for schematical electromagnetic temperature and for the evolution of first solid to liquid phase of liquid to gaseous phase, but it is 3D solution in the hard coupled for utilization would be extremely difficult and complicating unexpected long. The model proposed by the authors approximately for the physical reality that arrangement of induction assisted laser welding. Two plates are welding wheel denoting velocity of laser beam inductor can be of industrial practice verified calibrated experimentally. The quality of welding is usually evaluated by depth D and the microstructure, the parameters and the inductor welding and the material inductor nevertheless, and the first step to done is compared to thermally affected zone welding prepared and real and the same zone model using the same material and characters we provide the manufacturer. The only condition is the maximum temperature of measured sample and model case are the same often result of comparison, and the isotherms I1, I2, Im and Ip are denoted isotherms of melting point of the heated material obtained using both approaches usually differs even when they should be theoretically be the same, providing that all the input should geometric and parameters of the laser and inductors are identical. Reason highly probable consists in the difference between the material characteristics. Third, the method of solution. The method of solution is seemingly very easy. First, in the heat effect zone and even outside, we choose endpoints whose temperature T1, T2, Tn green points obtained on the measured simple T1, T2 and Tn blue points. Get to the stimulation of transfers cut through the welding part of the temperature experimentally from the analysis of the microstructure material characteristics are not even left part of the shown and the sample of obtained and from the numerical simulation and given characteristics obtained by modeling and introducing that object functions in the form of that has been minimized. The characters are supposed to have form of functions with known coefficients. The object functions the minimized respect to functions. The selection of tolerance of iteration process the finding the coefficient of the above functions that would be provided as approximate of incurrent characters as possible. The coefficients represent the zero theory, the initialization of process, selection of new coefficients, computations of the corresponding forward task and new value of object function. If the object function is smaller than the tolerance, stop. If not, step 3. The most time demanding part of the solution is forward. Targets that represent hard coupled 3D, nonlinear and non-stationary problem characterized by the interaction of electromagnetic field, temperature field. The electromagnetic field produced by the inductor C is described by the equation the magnetic vector potential A that obeys the equation. In our equation, sigma is the permeability denotes that electric conductor is V stands for the velocity, motion, and G is the density of current delivered existence. So the boundary of condition along with a sufficiently distant boundary is of directly type. B. The temperature of field by the inductor. The heat transfer equation is generally from reach of here W represents the voltmetric internal source of the heat in the process of material, and T is the time the voltmetric heat, and the source W is are the represented by the specific joule loss Wj and specific hysteresis loss Wh, and thus W is equal to Wj by Wh, where the losses Wh can be often neglected as their value is just a small fraction of loss, and Wj the boundary conditions respected both convention and radiation is expressed here. Ts is the temperature of surface of plate A denotes the coefficient of the convection and heat transfer T0, and for temperature surrounding medium air is the Stephen voltage constant. C represents the massive of heating part. Tr is the temperature of the surface which heated is rated. C is temperature field produced by laser beam. Heating by laser beam is respected by a boundary condition starting from the power delivered to the spot irradiated by the beam. The basic transfer equation: heat is supposed to be delivered into the material from the spot surface heated by the laser beam, and this may be taken into account by a boundary condition that is similarly but contains one more than corresponding to the delivered thermal flux. Initially, the condition is given the actual surface temperature of the body depends upon the preheated post-heated deep flow field. The flow field of the produce at the spot irradiated by the laser beams after reaching the melting temperature of the heated at the spot. All three phases, solid, liquid, gases, are the mutual interaction which called the Hall effect. A phenomena is described the reference. The other modeling is time demanding that Y is offers another method for mapping that the phase dynamic deformation geometry applied on the calibrated shape of keyhole. The result do not reach the accuracy of full model, but the competition time is by 1 2 orders shorter. More detail can be found. Thank you.